I think that's just about time, so I'm going to make a start. Firstly, I'm going to start by apologizing. I didn't realize it was in such a big room, and I was going to have a camera in front of me, so I've worn shorts, and I'm now having my legs streamed live on the internet, which is awesome for me. The shorts are a sign of rebellion. I was actually made an Australian citizen on Monday, so I thought naturally I should come along in shorts. I skipped out the thongs because I thought it's a classy place, better not put thongs on. So my name is Lewis Benge. I'm a lead architect from one of the retail banks down in Sydney. I'm here today to talk about cross-platform line of business applications, specifically looking at some of the Azure mobile backend as a service functionality. The reason I'm here today is I'm an ex-Microsoft MVP of 5 years, specializing in the Windows mobile and embedded space. Since I've been in Australia over the last decade, I've worked predominantly in the retail environments, spanning embedded, IoT, and particularly mobile. So this stuff is a passion for me. I've been working on it for a long time now. This is like my 7th Ignite Tech Ed, where I've actually talked about similar types of problems and how we can solve that. As the maturity of Azure actually kicks in, it gets easier and easier every time I come and talk about solving some of the bigger, harder problems, especially when we talk about line of business integration. So I am an architect, so I wanted to start with a couple of boxes. Unfortunately, I don't have a whiteboard to draw them, so I stuck them on a PowerPoint slide instead. So this is a classic mobile architecture. This is exactly the same architecture that I have in my consumer retail apps, and it's a very similar architecture to what I see in most enterprise apps that we pick up. We talk about a couple of tiers with mobile. We have the client, which is obviously essentially now a thick client, iOS apps, Android apps, and now the HTML5 offline capability is starting to see equivalent functionality pushed down into the browser as well. I commonly talk about an edge perimeter as being the first back-end service that we talk about. And the edge perimeter has a couple of important concerns. Predominantly, though, we use it for identity and security. It's that shield that ensures that whatever is coming through the front door is integral to and protected and safe for us to consume. In mobile, we also use the edge perimeter to dumb down payloads, especially when we're connecting to things like Unix applications. Predominantly, that integration is coming out from some large SOAP payload. We like to use the edge perimeter to dumb all of that down into something that's consumable from a view model within the mobile app. Out of everything in that edge perimeter, the two areas that I want to talk about and focus on today are the two important ones to me, which is identity management and data consistency. I kind of feel that if we can get security right for line of business and we can ensure that there's a seamless authentication process that allows us to log in using our corporate credentials and doesn't continually force us to doesn't kick us out all the time, makes it frictionless, makes it easy, people are going to start to use them apps a lot more. The other part of it is obviously data. So when we're serving up data from a line of business system, we need to make sure things are correct, they're represented perfectly, but also just the nature of mobile is connectivity isn't an omnipresent thing. So we need to look at different concerns around bandwidth capabilities if we're on Wi-Fi, if we're on 3G. And obviously, when we start to look at roaming enterprise, you might have people out in rural areas that won't have connectivity all the time. The other parts of that we commonly talk about in the enterprise architecture is then an API gateway and some form of enterprise application or integration layer. That's our app tier. We use our API gateways, and we're starting to see these through the Azure stack as well now as a way of looking at a form of enterprise service bus as kind of orchestrating different backends together, as a way of actually managing who's consuming what applications, so we can actually deal with things like semantic versioning. We can push out new versions of APIs with breaking changes without breaking clients. And then from a line of business perspective, we always have the enterprise systems that we need to connect to. And when we're dealing with line of business, just as we're dealing with consumer apps, we don't always have the glossy, shiny, let's deploy everything on the cloud and everything is a nice REST API. We normally have some quite complicated things in the mix, and it normally means that we jump on-prem, off-prem, and a combination of there in between. So luckily, Microsoft has become aware of this, and they're starting to help us out to get things up and running as quickly, as efficiently as possible. So Azure have, I think this product's recently been named to mobile apps, but when I started to put this stuff together, I've labeled the slide mobile services. It's a package of mobile components that we can start to use as a way of building up enterprise line of business mobile applications. And when I talk about mobile, this is predominantly looking at iOS, Android in native code, so Swift Objective-C, or Java for Android, is looking at it from a Cordova or a PhoneGap perspective and all the derivatives in between of the Cordova forks, HTML5 and JavaScript, as well as obviously Microsoft recently acquired Xamarin, so a true cross-compatibility .NET compiler that allows us to build this stuff. What they're actually providing us is a set of tools that allow us to do quite powerful things. So the first thing is on the device, they're providing us capabilities around data management. So offline, online sync around data capabilities, and ways of integrating into the downstream systems, such as authentication, notifications, and any APIs that are being built up. Those mobile SDKs that you see on the left-hand side of that slide, they're all a very seamless, managed, easy-to-use SDK. They're not designed for you to be code-genning your own data contracts and things like that. It's there for you to get up and running pretty quickly. From the mobile backend as a service perspective, there's a whole load of capability that's been introduced. So, as I say, offline sync is there. There's an array of different data connections from a data storage perspective, so classic SQL, the table storage, Mongo NoSQL, Office 365. There's a whole range of out-of-the-box authentication providers that you can start to literally pick up and run with. So the classic B2C style, Facebook, Twitter, Microsoft accounts, Google, as well as Azure Active Directory, which lets you authenticate both against Active Directory in Azure and for those people using Office 365, but also federate back on-prem, so using your existing LDAP and Active Directory connections to connect through. The other thing that they've done the heavy lifting for us is push notifications. If anyone's ever consumed or used push notifications and stood up their own server, especially if you're trying to do this at volume, you know this can be a pain, especially dealing with the multiple notification providers. Microsoft have solved this for us, and they've aggregated it into a nice holistic API we can consume. As the ecosystem grows out, sorry, I've gone too far on my slides. We're also starting to see other connectivity pieces get stood up. So the amalgamation of when mobile services has now moved under the concept of this API app, and we get all the benefits that have come along from the Azure ecosystem along with it. So this is seamless deployment from GitHub, from TeamCity, from Bitbucket, from TFS, the A/B deployment scenarios, the staging environment, all of that is now part of this solution. As well as things like the BizTalk connectors. So when we're talking about line of business and having to integrate into downstream systems, a lot of what we're talking about here and the demos I'll show you today will use the lightweight, easy to consume things like SQL and table storage. But you can just as easily plug this into the BizTalk Azure services and actually go back on-prem and use those BizTalk adapters to connect into some of those line of business solutions as well. So as I say, this is all wrapped up as part of what was traditionally Azure Web Apps, previously known as Azure Websites, and this is an extra layer of mobile goodness that sits on top of these APIs. That means that we get all of this stuff for free, and it means that we can scale up these enterprise APIs to enterprise standard very quickly, efficiently, and cost-effectively. Some of the key call-outs here, we saw in the keynote this concept of web jobs, these scheduled processes that can sit in the background, can churn and mine things for us, and can do something. When we talk about asynchronous processing and push notifications from mobile, web jobs are a classic example of where that would come in. Is we could set up a 15-minute schedule every so often to go and query a database or process something on a queue and notify a user that something's completed via a push notification. So I want to take a quick tour around Azure mobile apps and specifically the solution that I'm going to be showing you today. So I'm going to jump across to my Mac, And the way I'm actually set up today is I have a MacBook Pro running Parallels with a Windows 10 build environment, which is what you can see on the stage. But I'm actually compiling down onto OS X, and I'm deploying onto the Xcode simulator to run an iOS client. So the first thing I want to show you is exactly when we're talking about mobile and we're talking about Xamarin, what exactly the solution looks like. So this is kind of a Xamarin 101 for people that aren't overly familiar with the structure. So this bit isn't specific to Azure. You can pick up the Xamarin toolkits. You can go to the Xamarin website and kind of learn this stuff. And it's now free as a community edition with Visual Studio Community Edition for people to play around with. So specifically what I have is, this is a Xamarin Forms project. I've gone file new Xamarin Forms, and it's actually spun up inside Visual Studio 2017 with a Xamarin Android project, a Xamarin iOS project, some shared codes, and I've gone and added a PCL because there seems to be a bug in Visual Studio 2017 at the moment where you can't choose between shared code and the PCL libraries. I've then gone and installed a MVVM framework called Calibre Micro. This is one of my preferred MVVM frameworks for UWP, for any kind of WPF, as well as it now fully supports Xamarin Forms. So inside my portable class library, I've got a series of view models and a series of views. The way Xamarin Forms works is there is a customized version of XAML, which is the markup language that's used within most Windows products, that actually allow you to simply go in and code a generic interface using controls that you should be familiar with if you've ever used the Windows stack before. But when you actually hit debug and this compiles, it will actually convert all of these controls into the equivalent controls on the stack that you're trying to deploy to. So what this won't do is this won't create a Windows-looking app on iOS. It will actually convert all of these controls into iOS-like controls and actually make it look more iOS-y when it deploys. So I also have my view models. I'm decoupling all of my business logic away from my views. So my code behind on them XAML files is actually completely empty. And what I'm doing is using the MVVM pattern to push bindings backwards and forwards. So if you're a XAML developer, you'll be familiar with this concept of being able to bind to properties, push data backwards and forwards, as well as having particular command methods on my view models to execute things like button presses and stuff like that. So the way I've actually stitched all of this together is all of my core code around Xamarin Forms sits within this PCL library. It's reused against both Android and iOS, and that's most probably around 95% of all of my code. So I'm getting a lot of reuse here. There are, however, some things I can't do, and that's code that's got specific dependencies on platform-level APIs. So if I need to know what the current active view controller is on iOS, that can't be abstracted away. There's no commonality there with the navigation stack on iOS and Android that would allow me to do that. So I'm actually using dependency injection to reference data back up again. So a good example of this is I have this concept of an authenticator, which I'll talk to in a minute when I start to talk about authentication. I have a reference to an interface in the common library, but I'm using dependency injection and IOC to actually take the concrete implementation of that interface from iOS and push it back up into that common library. So that's the structure of my client. And I'm going to play around more with client code than I am with server code throughout this demo. What I'm using for the server code is essentially a web API. It's a special type of web API built around the mobile backend as a service, the Azure mobile stack. So the way you actually get here is you can go along and create a Azure mobile app. You literally go file, new solution, Azure mobile app. And what is spat out of the other side of that is exactly what I got open in this solution. So it looks exactly like an MVC web API. If I open it up, I've got a controller called a to-do item controller. And this has actually got a base type of table controller. So the first thing that the Azure mobile apps actually do is they start bootstrapping code around entity framework and OData and the serialization of that data back out to the internet. So this table controller is based on top of a object, which is this to-do item which has a really simple structure of the text that you want to do, the reminder, and whether it has or hasn't been completed. This is then pushed back into a entity framework data context. I'm so glad that that pops up. So I've got this data context here. This should all be familiar if you've ever used entity framework or even linked to SQL. Very, very similar concepts here. This is all bootstrap stuff, and it actually connects back to a SQL Server database hosted on Azure. The actual API itself is, as I said, it's a base type of table controller. The table controller is actually inherited from the standard API controller, but does all the bootstrapping around connecting to the entity framework and running the queries. They're actually hard-coded in to serialize the data back out as an OData package. Azure mobile apps are very OData driven. It's an easy way of us being able to pass queries backwards and forwards and interrogate APIs while keeping the payloads fairly light. It also means that we get to do some quite interesting things with less code as well. So what you'll actually notice here is that you've got standard style of CRUD updates, so being able to create a new or add a new record, being able to update that record, and then being able to do things like retrieves and deletes as well. What I've actually done is I've then attached this to a Azure mobile app service. So the way I've actually done this is I've gone through and deployed this within Visual Studio. I've gone through, right-clicked, hit the publish item. I've created a new profile. That's pulled all of my Windows Azure details and created up a new API and connected the SQL database and all of that for me. You can also do this within the browser. So if you wanted to actually see what's being created and be sure about what resources you're spinning up and exactly how much you're going to get billed, you can actually just go through and create a new mobile app through this through the file new system within the Azure portal. That will go through the same process and the same APIs as Visual Studio is doing, but it's more fine-grained in terms of the preferences you can have. At this point, you can determine whether you actually want to create a project that's based on SQL Server or storage data or Mongo data. You can plug in your BizTalk capabilities. You can define the pricing plan. You can go all the way up to the big enterprise-grade machines to the free tiers. Once you've actually opened this, once you actually deployed the solution, you can then go and play around with it inside Azure, and I'm sure many of you have seen the Azure portal before. But essentially, once it's uploaded, it is an API. Very, very easy to consume. And I can go through, and as I say, I've got that full power of the Azure website APIs. I can go through and I can set up scheduled jobs. I can create deployment scenarios. I can set up my CI/CD pipelines. I can upgrade, downgrade, scale all of this to what I need it to do. So all of that, honestly, took me about 15 minutes to set up about 10 o'clock this morning. So pulling that together, bootstrapping all of that code, and actually getting a functional app that I can compile onto iOS that pulls this data down and renders it out via the XAML was a 15 to 30-minute task, depending on how nice Visual Studio wants to be and how many exceptions that it's been thrown at me when I'm trying to compile stuff. So that's kind of the 101 I wanted to go through. I now want to dive into the security stuff. So identity for me is an integral part of enterprise development. It's all well and good when we do consumer apps because we have full control around the authentication provider. I've built many a website whereby you go and create a new ASP.NET membership provider that's storing details in a SQL server somewhere. Or you're using things like Facebook and Twitter to log in and you're just getting a reference to a particular identity. But when we're doing enterprise, we want these things to be frictionless and easy. So we want to try and use the single enterprise credential to make it seamless for our user, but also from a security perspective to ensure that we're not having these fragmented security stores all around the place, that if someone leaves, they could still have potential access to the data that's been exposed via the mobile app, or even worse, the API set that could potentially sit underneath it. So the way we actually get around this with the Azure mobile backend as a service from an enterprise perspective is we actually start to look at Azure Active Directory. And this is actually really, really easy from a mobile perspective to get up and running. Again, it's most probably a half-hour exercise to actually get your API and your client connected to Azure Active Directory, and for you to be able to log in and get the tokens back again that you can start to authenticate. The reason it's so easy to do is there's a library out there called the Active Directory Authentication Library that allows us to quickly get up and running, and it does all the heavy lifting around the actual OAuth and OpenID flows that are going on under the scenes. That means we can be slightly ignorant around how the flows are actually working, and we can just focus on getting our code up and running. The ADAL library is available as a multi-platform library. It's actually deployed as a portable class library, and is available across a whole host of different stacks, including Java and Node.js. It's also available now, or coming as a .NET Core package, so we can start to look at these things on cross-compatible ASP.NET implementations as well. So the way this actually works in my project is in my portable class library, which sits against these. I've actually got 2 of the 3 projects there, the iOS and Android. I've got a single piece of login code. I've then used that dependency injection concept to actually get client-specific, platform-specific code up and running, and pushing the result of that back into the common business logic and allowing that to actually drive the views. The reason for that, and the reason I'm having to use platform-specific code, is what the Azure Active Directory Authentication Library is doing under the covers, is it's actually spinning up things like UI web controllers and web activities inside Android to render the same login box that you would see when you're signed into Office 365. It's then going through all of that authentication flow inside the browser, and then it's extracting a cookie once it it's extracting a token once it ends that flow, and then passing it back into the native code. Because it is a browser-based authentication flow, it means that we need to look at the particular local implementation of iOS, Android, and Windows around how them browsers are working. They all work very, very differently, so we do need the platform to step in and help us. So what this code starts to look like and how easy it is to get this code is something like this. Sorry, I didn't realize I had so many animations in my pack. We have a concept of an authentication context. We actually pass in the URL that we want to authenticate against, which is going to be the URL of your Active Directory implementation. We then go and request a token, which we pass in the particular resource URLs and the authentication URLs we need, and we get an authentication result back again. That authentication result is actually quite rich. It gives us a token, which is a long-living token, and can last for X amount of time, depending on what you configure at the back end. It also gives us the directory information of that person. So it gives us their name, their email address, and anything else that's configured in their directory profile that we need access to. That token, as it is an Active Directory token, can then be used against multiple line of business systems and not just the API you're specifically targeting at the system. So as an example, and in a session that I used a slide for last year, I can actually use the token that I'm generating from Azure Active Directory to hit Office 365 and Office 365 API set. I can also use that to consume the Microsoft Graph, to consume data from Yammer, to actually go into other systems like Salesforce as well. So if I want my client to do a level of orchestration for me, I can just use this token and actually ensure the permissions are correct on the back end to kind of pass it backwards and forwards and have this seamless connectivity state. It's great for me because, as I say, it is Active Directory, and this can federate all the way back onto prem. So if I then ever leave the company, my Active Directory account will get suspended, these tokens are then disregarded, and you can no longer authenticate. If you couple this with MDM, it becomes a nice, seamless and frictionless way of enforcing enterprise mobile app deployment. So the version of the Active Directory Authentication Library I'm currently using, as I say, is version 3.x. For both desktop and Xamarin, it's actually got an inbuilt cache, which is actually really handy because when you authenticate against the Active Directory, it gets annoying to type in your username and password every time you load the mobile app up. So what it'll actually do is it'll hold a reference to that token if you want it to, and when you need to launch the app, And if it's been pushed into the background and it awakes as part of the app lifecycle, or you actually have a fresh launch, it'll actually just pull a token out as long as it thinks it's still valid from the timestamp that's issued, and it will attempt to authenticate on it using that token. If that token is no longer valid, it will then push you back into the classic authentication flow. This stuff is, as I say, very generic. There are a couple of quirks depending on what platforms you're actually deploying to. If you're going old school and looking at Windows Phones, Windows Phone 8, and even Windows RT for people that are still deploying Windows 8 and 8.1 apps, you'll have to look at things like potentially deploying custom variants of this because it has some dependencies and nuances to it. But I actually want to talk you through exactly how to get this up and running from a mobile perspective, because there are a couple of parts that come into play around how we bootstrap both the APIs and the client to actually get these tokens up and running. So I'm going to jump back onto my laptop. And the first place I'm going to start is actually in the browser. So what I want to be able to do is go into my mobile backend as a service and actually say to Azure Mobile, I want to be able to authenticate against the project that I'm working on. So the way I do this is I have this authentication and authorization tab that I can use. So if I click into here, what you'll see is, as I mentioned earlier, you've got now a selection of which authentication providers you want to use. And these are the ones that are currently supported out of the box. So I've already configured some of this stuff. So I've already gone through and configured the Azure Active Directory, but I could easily go through and say, I actually want to support multiple of these. So I want to support Facebook and Google and Azure Active Directory. The trick to that is getting the support on the client, and I'll talk you through how that actually works and how we get the tokens back through to our APIs in a little bit. So if I actually click through, you'll see that what it's actually asking for from an Active Directory perspective is a couple of bits of information. And depending on how you actually get access to your Azure Active Directory will depend on how you go about configuring this. So for me, I actually have two separate accounts. I have my Office 365 and Azure Active Directory account on a separate Microsoft ID to what I'm currently using for my Azure portal. So I have to do things the advanced way, the hard way. I have to manually enter parameters. If you actually got all of that under one account, you can actually just go on that Express button and select which Azure Active Directory you want to deploy to, and it will actually configure all of this for you. If you need to do it the hard way, and I know a lot of people do because a lot of admins, network admins, don't trust developers playing around with the Active Directory, you'll have to go and ask for these particular pieces of information, which means you'll actually have to dive into the Azure Active Directory part of the portal. So for me, as I say, that's a completely different account, so I'm actually jumping to a different browser instance. And I'm actually doing this in the old portal just because it's easy for me to show you how to get access to this information in the older portal than it is in the newer portal, because it has moved around a little bit and it's not as obvious, and I'm really hoping they're going to tidy it up. So the first thing you'll notice is I've got a couple of different applications here. So if you look at, my Active Directory is lewisbench.net. That's what I use for my Office 365 account. And this is where I'm currently logged into, so I can see my users, my groups. I have a tab called Applications. This function does exist in the new portal, but it exists in two different types. I think it calls one Enterprise Applications and one Applications. It differentiates between the apps that you are building, which is what we're looking at now, versus you federating with things like Salesforce and third-party marketplace apps. Enterprise Applications is a premium function in Azure AD that you can't support out of the box with just an Office 365 account. But for stuff like this, I've just got the base Office 365 connectivity, and I've created Azure AD as a result, and I have access to be able to authenticate against my own applications. You'll see I've got a couple of different applications here. So I've got some demos from last year, which was when I was playing with the Graph API and UWP, and I've got my stuff from this year. And I actually have two different implementations. I have the Ignite Demo web application and the Ignite Demo client application. The first thing I want to talk about is the actual web application, because that's the piece that's actually doing most of the authentication flows. So the way I've gone about creating this is I've gone and created a new application, and I've literally gone and said it's a new web application, and I've defined a couple of parameters. The parameters I've provided are exactly these ones here. So I've given the application a name. It's actually important you give it a sensible name because the user will see this when it signs in. So if you just give it some developer-centric name, that will actually appear on the login screen when people attempt to authenticate. I've given it the sign-in URL, which is the actual mobile backend as a service API that I've deployed. So it's that Ignite demo API plus the timestamp, which is what Azure has actually created for me. You can customize the logo, and you can go through and do a whole load of customization around what the login screen should specifically look like. And a lot of this is focused on a web-based login. So obviously, I don't want a web-based login. I haven't really gone through and customized any of this information. The output of that is it's generated me a client API. I need that information. It's actually one of the things that's requested in my Azure Active Directory settings as part of the MBAS within the other Azure portal. So that parameter there is the same as that parameter there. The other important thing I've given it is a reply URL. So from an online perspective, this isn't too much of a big deal. This is kind of just closing this is the callback URL that will hit the API, and we don't do much with it from an API perspective. If you was using an online application, a HTML-based application, this would be important because you'll want the callback URL to hit the next stage of the UI that the user would then pick up and run with. Where it is important, though, is ensuring that you capture the reply URL and ensure that when you implement it on the client, they're consistent. Because what will happen is as the UI web view or the activity in Android is ticking over, the actual Active Directory authentication library is looking for that URL to hit in the particular event. And then it will intercept, it will strip out all of the payload out, and it will hand it back to the native app and then destroy that UI component. So I've gone through and I then created my API, and the other part of this I can select down the bottom is I can then give this particular Active Directory permission to actually sync to other applications. So this is where if we wanted to use the same API token to connect to the Microsoft Graph API, to things like Intune, Office 365, Power BI, we can actually go through and delegate it, and you can actually go down into quite fine detail around what claims the particular user can make against those APIs. So this is important, as I say, if you want the API that you're creating or the client to do the orchestration around third-party systems. You need to ensure you've got the breadth and scope of these permissions in this particular claim, otherwise you'll just get rejected when you try and hit the other API sets. So the other piece that normally gets everyone as well is when you go through to this Active Directory settings within the Azure portal, which I've managed to lose. Is it asks for something called a issuer URL, and nowhere in the portal can you actually find anything called an issuer URL. So not in the old portal, not in the new portal. The way you actually get this parameter is you hit this button down the bottom here that says View Endpoints. You go up into this top link, which is the Federation metadata document. You actually then open this in a browser, and you get the XML payload download, and that URL you're after, as seamless as it sounds, is actually this URL that's at the top here. So that's actually the token issuer URL, and this is the only way you can find it. So why this isn't more seamless in terms of being able to expose this data, I'm not sure, but this will actually get you up and running fairly quickly. As I say, if you are using the same Azure portal as your Active Directory, all of this is fairly seamless. You literally go in, select which Active Directory you want to use, and it's like click, click, next, and you're done. You don't need to worry too much about this. So once I've done that, I can actually save all of that parameters that I've passed in, and I've now got a level of protection on my API. So for people to come along and authenticate against my API, they're going to need to pass me a token that's issued from my Active Directory. The actual wiring up of that into things like the web config file is done by Azure mobile apps when you actually deploy it into the cloud. So it's going to inject all the parameters you've just set into the web config. It's going to switch the web config on around what it's going to protect, and that will just start getting up and running. The problem you've got, however, is because this is an API, you're going to need to configure a client as well to be able to get access to this. So this means going back to the good old Active Directory portal and creating a second app. And that second app is slightly different because it is called a native app. It's a client app. It has slightly different flows. So again, you give it a name, which is the name that's going to appear when you log in. You give it a client ID, and again, you give it the redirect URL. This needs to match to the redirect URL that you've previously used because you want to try and keep the things in sync. The other part about it is we need to allocate permissions to the API that we've just created to say when you get this token issued, it can access the back-end API as well as anything else you need it to access. The way that these things sync up is by looking at commonality between things like the redirect URL. You can then go in and go add application, and then as you'll see, if I go to all apps, it doesn't appear, but if you actually have a look here, I actually ended up using the new portal for this bit because there was a sync problem with me creating the previous application and this application, but you'll see my Ignite demo is here, and I've explicitly assigned permissions for my client to then access that API. So now all of that's wired up. So how easy is it to get into Xamarin and get something up and running, authenticated, and logged in? So if I jump into Visual Studio, I'll show you exactly the amount of code that it takes to get this working. So firstly, from a commonality perspective, I've created something called a iAuthenticator. This is part of my dependency injection framework. This is the interface that I'm going to use from my view model that allow me to authenticate against Active Directory. The actual implementation, though, is down on a concrete level, is done in the platform. So I have an authenticator class that's doing the concrete implementation of this. And it's this exact amount of codes that I pretty much showed you on that PowerPoint slide. So what it's actually doing here is it's saying, create a new context with the authority. That's passed in. The authority is actually defined as a constant on my view model. It then goes into the cache. I've talked about having these persistent caches, and it's basically saying, is there a user that's already got a token that we've previously downloaded? This protects the back end. It stops you going backwards and forwards for continually asking for new tokens, and it also makes it nice and easy for the user to log in. If there is a token now, it will just automatically take that token, inject it into the framework, and pass it back out again. If it doesn't have a token, it will then go online and go through the authentication flow. The platform-specific nuances here is it's doing things like this. So it's actually looking for the particular root view controller in iOS. As I say, this is going to pop up a UI web view controller on the navigation stack on top of that root view controller. So it needs to know these specific implementations, which is why it's not done in the PCL. It's actually done on the platform itself. It's then looking for the return URI. This is the thing that we've gone and defined on the back end to say once you hit this particular point in navigation, break out and hand back again. It goes off, fires that all into a nice async method, and then returns the authentication result. The Android equivalent is identical apart from these two lines of code. So on Android, it needs to know the current activity that's in play as opposed to the root view controller. The rest of the code is very, very similar. And then to actually log in, I actually do all of this in a login view model. So I've defined a couple of constants or static strings up the top here. So I've defined which particular resource I want to access. As I say, that depending on what you do want to access, you could change this to graph.windows.net, or you could change it to api.office365, and that would allow you to go and make claims against those particular resources. I've defined the authority to say I'm actually logging in against the Azure Active Directory. I've defined my client ID, which is the client ID that I've generated for the native application inside Azure AD. And I've also defined the return URI again, which is the same as the one that's put on the back end. IOC kicks in up here, so all of this is constructor injection from the Calibre micro framework, so I'm not having to worry about actually looking up any of these particular concrete implementations. It's all done for me. And then what I'm actually doing is I'm calling this authentication service, which is what's actually executing on iOS. I'm getting back this auth result, and this auth result is a rich payload of information containing the token, the expiry date, as I say, all of my AD properties and things like that. Once that completes, I then can just pass on to the next page because my tokens come back again and I'm fully authenticated. So this compiles and runs quite nicely on iOS. So if I hit debug and everything goes according to plan, it will actually spin up on the iOS simulator on my Mac. So as I say, I'm an architect. I'm not a designer. I'm used to drawing boxes, so I have a single login button. If I click this login button, that will actually implement the actions to complete the login flow. And you didn't see anything. The reason you didn't see anything is I don't fancy putting my username and password on stage, being streamed live to the internet. But what you will see down in my debug log is the token. So what I've done previously, just before this presentation started, is I did log in. And the expiration time hasn't kicked in yet. So what it's done is it's gone onto a device and retrieved my credential, my token, from that cache, and it's passed it back to me. If I would have put a breakpoint in here, you would have seen from that auth result, it would also given back my name and my email address as well. So I can then do things like personalize the next screen. So the final two steps around securing both our API and anything else we want to consume is, at the moment, this is just going off to the Azure Active Directory APIs, issuing a token and handing it back to the client. We need to ensure that any subsequent calls through to the mobile service APIs are going to be authenticated against. So we do that using these 3 lines of code here that I've commented out. So firstly, the way this is going to work is it's going to take the token that I've just been issued, it's then going to insert it into a singleton implementation of the mobile service client SDK. So this is the single point you use to go and interrogate anything you create in this mobile backend as a service. It will take that token and it will either store it as a cookie or it will use it, keep it in memory and append it as a HTTP header depending on the particular authentication flows it uses. But the way this particular API is looking at me doing it is it wants me to create a JObject, which is a JSON object from the JSON.NET framework. I'm defining the name, the key value name as access token, and I'm passing in the token that's been supplied to me. And then going through to the actual mobile service client. So this is Microsoft's client, their code from the SDK, and there's an async function on here called login. I'm saying that this is a token for Azure Active Directory, and I'm passing it the JSON payload. As I say, this will go through, it will append all of this information, so any subsequent requests I make through the SDK will automatically be authenticated using my token. I said earlier that depending on how many providers you implement, this flow will change. This is the reason for it. So this is an enumeration here. If I went through and said Facebook, I'm going to have to go through and ensure that whatever tokens I'm getting back from my client implementation, I'm then matching up to say this is either a Facebook or a Google or an Azure Active Directory, and ensure I'm coding it out appropriately. Obviously, you wouldn't use the ADAL library to get a Facebook token. You'd use the Facebook ID libraries, which do exist, that you'll be able to pull that code down for, and it'll be a similar amount of effort. So what this gives you is that level of flexibility to say that if you did want to use this in a B2C environment or even in a corporate environment whereby you may be using something like Facebook at work, you could go out and say, do you want to log in with Azure or do you want to log in with Facebook or Google or whatever you need to? The other part is I also need to ensure that my API is going to be protected. So the way this works is I jump down into the API controller. So if I jump back down into my website implementation in the to-do item controller, this is the same as anything else that uses things like the membership providers within ASP.NET. You just put the attribute on top of the class that says authorize, and this will ensure that no one can access this particular API unless they've got the right token issued to them. At the moment, I haven't been granular around claims, but you can actually customize this attribute to extract the claim set that's coming back from Active Directory and say if you're in particular groups or have particular properties, you may only have read access to this or write access. The way you'd most probably do that is instead of putting the attribute on the class as a whole, you're going to stick the attribute on the individual methods within inside the API, and then that way you can define that this write-only method may only have access to a particular AD group. So that's all authentication. So I'm now up and running around being able to authenticate against my Active Directory, get the tokens back again, and authenticate against my API. In total, when I pulled this demo together, I'm most probably now on about 45 minutes of effort. Although my app doesn't look amazing, it is a single button. For me to be able to create an iOS and Android and a Windows app, hook it into Active Directory, create my API, get my API authenticated, get the tokens moving backwards and forwards in 45 minutes is pretty amazing. So in the last half an hour, I want to just quickly touch on data and sync. So the other thing that the MBAS service, the Azure mobile apps actually offer us is a great way of being able to expose data quickly and efficiently. So as I say, that mobile apps have different concerns to when we think about traditional thick client and web applications, in that network can drop out. I know that there's colleagues here from the New South Wales SES that have done work in this space, and there's continual talk about how do you get mobile apps working more effectively in places like rural areas. Microsoft's been thinking about this, and the SQL, some of the SQL Server work, the SQL Sync work, is hopefully trying to solve some of these issues. So one of the principles that we try and look at when developing the mobile apps is adding offline sync to an app is usually quite hard, but it's actually the most effective way of us being able to create a effective UI and ensure some seamless transitions, some seamless effects. Because what we want to be able to do is read from a local data source and use that to bind against our UI, and in the background continually refresh the data backwards and forwards. It's a true async model, and it means we never have them blocking UIs that make things look like they're going to crash or they're going to hang. It also means we stay within the thresholds that people like Apple and Google set us around being responsive and apps not hanging or causing issues. So as I say, why use mobile data sync? So responsiveness, because you're going to get data locally from the database, but also you're not going to hit the server as much. If you're continually binding UIs based on continually hitting the server, it means you're going to increase your server usage. And when you're using things like Azure, which is essentially pay per use, you don't want to hit a server every single time that you load the mobile app and you're navigating around the page. It's very unlikely that data is going to change so regularly that you're continually having to hit the server. What you can instead do is use things like sync to read from a database and then get the server to push out data to you, or for you to continually poll in the background. I keep coming back to this part about network connectivity, but when we deal with retail banking apps, network connectivity has been a really, really big thing for us. So I remember in a previous life, in a previous organization, our most complaints were around dropouts. So if you switched between Wi-Fi and 4G, the network stack would actually change, and on things like Android, this can be devastating to the app because you get these network change events whereby you lose the outgoing connection, and if that's something like you refreshing a balance and the app just hangs on a retail banking app, it is really, really bad for an end user. The other part that people always have concerns around is conflicts when dealing with data sync. So if you want to be able to write to a mobile device and push to the back end, you always get this contentious issue of what if someone else is writing that same record. The mobile data sync capability within Azure Mobile Services helps solve that. It actually has a couple of different ways of actually managing contention around writing back to the back end as well. So the way this actually works is you've got your device, and we're actually using a capability within the device depending on the platform, but it's loosely based around SQLite. So within iOS, this is the core data framework. Within Android, it's a particular deployment of SQLite. within UWP, Windows Phone, and any other Windows derivatives. Again, we're using SQLite, and then HTML5, we can use some of the offline browsing APIs as well. We've put in an API on the front end that's allowing us to push and pull data from the back end. And the way it's actually managing this capability is it's timestamping data going in and out, as well as putting some other attributes and flags on some of the base classes of the data as it's being pushed backwards and forwards. This means the whole entire thing is bootstrapped for us, and it's really easy for us to get up and running. Typically, we do this inside a SQL database, but we can also use some of the Azure BizTalk adapters to push the sync capability back onto prem. We can also use this capability on the enterprise version of some of the Azure app services to connect to things like Salesforce, Dynamics, Mongo, and Office 365. And there are plenty of examples on GitHub that demonstrate how to use the sync capability with providers like that. The other piece of plumbing that we've actually seen come out of the Azure mobile apps recently is also the ability to sync files. So this actually allows you to take content from blob storage and actually pass binary files backwards and forwards without actually reading directly backwards and forwards from a URL. Too many animations. So I actually want to quickly show you how easy it is to get this up and running. So inside my code, the way I've actually implemented the client SDKs for Azure Mobile is essentially a repository pattern. If you're not familiar with that, it's just a way of referencing particular data functions and standardizing that regardless of the data source. So I've got things like create, delete, update, and that kind of stuff. So I call that my Azure Cloud Table, and it takes a type of data table. I then have a service implementation that's actually calling the mobile services client API. And then it's actually using my repository pattern as a way of being able to retrieve that data. So it's putting the repository pattern over the top of the Microsoft implementation, so keeping that abstracted away from some of my view models. So quite simply for me to actually get offline sync up and running, it's taken me a couple of lines of code. So first thing I've had to do is install a second NuGet package. So I negated to mention earlier today that for my mobile apps, I had to install a NuGet package called Microsoft.azure.mobile.client. So that's the one that gives you this client API as standard, and it does the majority of the functionality around authentication and retrieving data from the back end. If you want to enable offline storage, the other piece you actually need to deploy is the second NuGet package here, which is Microsoft.azure.mobile.client.SQLite store. What that actually does is it pulls down all the SQLite dependencies and the platform-specific implementation. So as I say, it wraps things like core data on iOS as well. So once that's in place, what I need to do is simply go through and initialize the actual databases. So SQLite being a very lightweight SQL-style database stored online, I need to go through and check to see whether it's been initialized. If not, I then need to go and use these new sets of APIs I've downloaded from NuGet, give it a file name to use. I then need to tell it what the structure of my database looks like. All of this code should be very, very familiar because it's very similar to what we do with the entity framework stuff. The to-do item is the model type I showed you earlier. And then I go through and call an initialize function, and that will go and create a database if one doesn't exist and ensure that the structure's there for me to store the data in. What I've also done is I've created a method called sync. So when we're talking about sync, there's two functions that can occur. There's a push and a pull. So we've written stuff locally that we want to push to the server, and then we want to pull updates down again. So all I've done is I'm using the client, and there's a sync context on the client that allows me to push data back up to the server. So it's going to take anything I've written back into that database I've just created. It keeps track of that, and it just pushes it back up. I don't need to worry about it. I don't need to write any code. It's going to do it all for me. I'm then going to jump down into my table, and then I'm going to get an update for it. So from an update perspective, if I jump into this method, the significant changes I need to make is I need to go from telling the repository pattern that I've created, not to read from an online store, not to hit the database every time, but instead to use the offline capabilities. So what I want to do is, instead of getting a table from the client, I want to get a sync table. This will keep track of all of the sync data. Has it been deleted? When was it last updated? All of the different attributes I need. I then change that in a couple of places in my code. So I take out the reference up here to just a general service table and change it to a sync table. And then I need to create another method on my repository pattern called a pull. What this is going to do, and the reason I've created this in the way I have and not just kind of bootstrapped the generic method straight from Microsoft, is I'm actually wanting to only pull down a certain amount of data. I don't want to pull down every single change to the database every time it's made, because it's going to kill bandwidth. And when we talk about mobile devices, it's important because any type of serialization is CPU usage, it's also battery usage. And then from a network perspective, if you've got poor or degraded networks, or you're on pay-as-you-go plans, you don't want to be pushing data backwards and forwards. So what I can instead do is actually just define which table, which query I want to be pulling down, and I can actually really shrink the footprint of what I want to sync backwards and forwards. That means if I only want to sync the to-do list, but not all of the users and all of the other reference data that's stored in the structure, I can do that. So that pull method is used in my service implementation to then pull that data down again. And then what will actually happen is, the nature of MVVM is this is all bound to the UI. So as soon as there's a refresh, the UI reloads from things like using the iNotify property change event that's actually raised from the view models. So all in all, I think there's about 13 lines of code. With me changing that out, I now have a full sync capability. I don't need to do any more. This is now pulling data backwards and forwards for me, reading out of that local database, and manage a lot more of my network concerns. So just quickly jumping back to the slides to talk about some of the other things just to think about when we're talking about sync, is when we're looking at enterprise level data, we don't necessarily want to download everything. I don't want to download the whole entire CRM system onto my phone. That's going to be dangerous, because if that app was ever compromised, I'm going to lose it. But also, the file size and footprint is going to be huge. So we can think about how maybe we customize this so we only download information based on the user. So as I said earlier, we have access to the user object that comes back from the Active Directory. So let's make use of it in the API. So the code snippet here is using the Active Directory libraries on the server side instead of the client. And what it's actually doing is it's calling in using the token and saying, get me the Active Directory object back again of this particular individual. And then what it's doing is it's actually using that identifier inside the database to match up the data. So here you'll see the link statement where it's agent ID is equal to the object ID of the person that's logged in. It's then only ever returning that data. So it's actually keeping the amount of data that's been sent back to the mobile device very, very trim and very, very small. It's obviously protecting the security of that data as well. The other way we can get some efficiencies here is leveraging the push capability inside the Azure MBAS, the Azure mobile apps, and actually getting the app to continually wake up to actually download data when the server wants you to download data. One of the traditional mechanisms you get data from mobile is by polling. Every 15 minutes, you wake up a background job, you hit the server. But if you're dealing with 1 million users, 500,000 users, 250,000 users, each hitting your server every 15 minutes of the day, it becomes inefficient. And again, it's going to drive up your network usage and the cost of the overall server consumption as well. So if you inverse that model, and this is where things like the Azure web jobs really come into their own, we can actually use push notifications to actually kick off this process for us. So some concerns from a client side: polling is quite heavy. It degrades battery, it consumes a lot of data, and as I say, server usage, it goes through the roof. So instead, what we do is we go through and use the push notification capabilities, which are part of the API set and part of the client frameworks that are in Azure mobile apps, and actually just register as a notification provider. Then you write your Azure web job, or you write whatever process you need in the back end. Again, this could be a process that's on-prem, and you're using things like Service Bus or webhooks to push up. And it could be the particular workflow says that when a CRM state gets to a particular level, and that's your client. You want to push a notification out to get their apps to refresh and pull that data down. We see this pattern all the time in Exchange. So Exchange uses the exact same thing of it will trigger a notification and tell the server to refresh. It's moved away a long time ago from the polling structure. So the way this actually comes together is when you send a notification, you send a notification as a silent notification. You never see anything appear in the notification center on the device unless you want to. There may be a prompt for a user to say, hey, load the app because there's a new incoming job. The notification then, a silent notification will actually wake a background process up on an app. It will, background process typically has a few minutes to do something. That is going to trigger a network call out. Network call will go down and use that pull mechanism the push and pull mechanism I've just shown you to sync the databases backwards and forwards. So the way, what this slide is talking to is essentially what I've just gone through. There's a concept within the Microsoft frameworks that makes it a little bit easier. It's called a tag. The notification hub within the mobile apps actually aggregates all of the notification capabilities. iOS, Android, Windows are all very different in the way the payloads work and things like that. If you go onto MSDN or the Azure portal and actually have a look at some of this documentation, you'll see how high level and how abstracted it is and how easy it is to get this stuff up and running. In the interest of time, I'm just going to skip over that bit. So the very last piece I quickly want to talk about is reference data. So one of the things, as I mentioned earlier, we typically store in SQL databases is this concept of reference data. So if you're driving UIs and you've got things like list of countries or list of titles, list of departments, anything that's fairly generic, if we're actually creating complex relational databases on the back end, we're going to need some form of that data to be sent to the front end. This isn't data that you want to be pushed through your APIs every time because it very rarely changes. You don't necessarily need to push down the whole name of a country if you could push down a foreign key, knowing that them foreign keys would relate to something on a mobile device. So the sync framework's actually really good for this, that when you initially bootstrap your app, you can actually deploy your app with a preloaded set of reference data. When you load the app up, you download and sync that reference data store, and then you push it on a fairly regular sync, getting the deltas as reference data appears. That way, when you actually build your APIs, you can shrink the overall footprint of the data that's sent backwards and forwards, and again, conserve battery, conserve network, and so on. So I know I'm running short of time, so what I'll do is I'll actually wrap up there. So just quickly summarize what I'm talking about. So Azure mobile apps is a way of being able to get enterprise applications up and running. All of the code I've shown you here today was written this morning by me having a cup of coffee while trying to refine some of these slides. It takes about an hour or two to get something lightweight up and running. And if you're looking at things like staff directories and stuff like that, it's a really, really good use case. It also has the power and complexity to get into more breadth and depth of large-scale enterprise applications as well. It has the security that's backed by Active Directory, both on-prem and Azure, as well as other authentication providers. That allows you to get to fine-grained level of control around the APIs that are being generated for you, as well as being able to perform client-specific implementations on mobile devices and use interesting things like if you wanted to use Touch ID on iOS and you can enable it within the toolkit, you can do that as a way of retrieving the tokens. It provides a frictionless modern experience for your staff. The mobile SDK is a portable class library. It's available for all of Microsoft's .NET platforms. It's also available for Node, HTML5, and a whole load of others. And it's a way of getting up and running very, very quickly, regardless of the stack that you're particularly looking at. So with that, I'm going to finish there. I've got 10 minutes left for questions. I'm happy to take up here, or otherwise I can come and talk to you down at the floor. Thank you. The room's really big, so I can't see if anyone's got any questions. No, I can't see any. So I'll be around for another 10 minutes if you want to come and talk to me. Thank you.